Hello and welcome to section 3 of our textbook, where we're going to start talking about polynomials. In lesson 3-1 we're going to try to learn what a polynomial is and learn about a lot of vocabulary that has to do with polynomials. On page 113 of your textbook, if you look at the learning objectives at the top of the page, I've highlighted here all of the different vocabulary words that are included: polynomial, term, variable, coefficient, constant, degree of a term, leading coefficient, degree of a polynomial, monomial, binomial, trinomial, polynomial, linear, quadratic, cubic. We'll also see the word constant. So there's one or two that actually don't even show up in this list that we'll talk about. Learning about this vocabulary is very important because it will be used a lot in the lessons that come after this. The lecture on our page begins by saying that polynomials are algebraic expressions created using numbers, variables, addition, subtraction, and multiplication. Now, at the core of polynomials are things called terms. And terms consist of just numbers, variables, and multiplication. So we take numbers, we multiply them by variables, and we get terms. And in the table you see some examples of terms. Terms can be just a number by itself, a variable by itself, or a product of numbers and variables, and sometimes multiple variables. For example, in the fourth example, 4.2 times g to the 7th power, we have 7 g's being multiplied together. That's what that g to the 7th is telling us. In the last one, we have 2 a's and 4 b's all being multiplied together. So we could write this out as -3 times a times a times b times b times b times b. The number part that goes in front is called the coefficient. So if we take a look at these examples in this table above the word coefficient, 15 is its own coefficient. X has a coefficient of 1. Remember, when we don't see a number in front of a variable, there's really a 1 there. The third one, the coefficient is 3/2. The next one, 4.2. And the last one, the coefficient is -3. So coefficients can be decimals, they can be fractions, they can be integers, positive or negative. They can be any number that we can imagine. This term, the first term we had that didn't have any variables in it, it was just a number, is sometimes referred to as a constant as well. And because it doesn't have a variable, it cannot vary or change. So we refer to it as a constant. More complex polynomials are created by adding and subtracting terms together. So in the 5 examples we see here, in the first one we have 2 terms, and we have subtraction that's combining them. In the next example we have 3 terms. One's being combined through subtraction, one through addition. In the next example, 3 terms as well. In the example after that we have 4 terms. And in the final example, number 5 here, we have a total of 5 different terms. Polynomials can have infinitely many terms. We'll keep the number much smaller than that, but they can have anywhere from 1 to infinitely many terms. In the first table that we saw, all of these are also polynomials. They're polynomials of just a single term. So we can have single term polynomials, 2 term, 3 term, 4 term, 5 term, and more, etc. On the next page, you're going to be asked to consider whether various expressions are polynomials or not. And really what you're looking for here is just to make sure that the only operations we see involving letters are addition, subtraction, and multiplication. The one thing we cannot do in a polynomial is divide by a letter. If you see division by a letter somewhere, you don't have a polynomial. So these first cooperative group problems are just yes or no questions. Is it a polynomial? Yes. If it isn't a polynomial, no. That's all you need to answer. On page 115, we'll talk a little bit about one way to classify polynomials, and that's to talk about how many terms a polynomial has. If a polynomial has 1 term, it's a monomial. 2 terms, it's a binomial. 3 terms, it's a trinomial. And 4 terms or more, it's a polynomial. And you'll notice this actually says any number of terms. A 1-term polynomial is called a monomial, but it's still a polynomial. Monomial is just more descriptive. 2 terms is a polynomial, but we can also call it a binomial, more descriptive. And again, a trinomial is just a more descriptive way of describing a polynomial with 3 terms. So they're all polynomials: 1 term, 2 terms, 3 terms, more terms. But for 1, 2, and 3 we have more descriptive words. If we jump back to the previous page for a moment, page 114, and take a look at the problems here. For example, number 1 is a monomial, one term. Number 2 is a monomial, one term. Number 3 is a monomial, one term. Number 4 would be a binomial, two terms. 5 would be a monomial, 6 would be a trinomial. So count the number of terms. Remember, terms are combined using addition and subtraction, so addition and subtraction symbols can be really useful for trying to separate terms and figure out how many there are. On page 116, you're going to learn a little bit about degree. Terms have something called degree, and degree just basically counts up the number of variables there are in a term. And we count the number of variables without using the exponential notation. So in the first table, we see our first polynomial or first term is just the number 5. There are 0 variables, so it is degree 0. The next one, 3x, the only variable is an x, 1x, degree 1 or first degree. In the third example, we have negative 4x to the second power. That x to the second power could be rewritten as x times x, so it's degree 2 or second degree. And finally, 2/3 x to the third. We could rewrite the variable part as x times x times x. 3x's degree 3 or third degree. If there's more than one variable in a term, we count all of them. So x times y to the second becomes x times y, 3 variables, degree 3. Negative 2, a to the third, b to the second. We have a times b, degree 5. And this much more complicated one, 15 times x times y to the third times z to the second. That's an x times y times y times y times z. It is degree 6 or 6th degree. When you get to the cooperative group problems here, notice that you're being asked to do two different things. You're being asked to determine the degree of each term, also name the coefficient of each term. And remember from the first page we looked at, the coefficient is the number part, the number in front of the letters, or if it's only a number, just the number part. On page 117, we take a look at writing polynomials in descending degree order. So far this semester I have not been worried about what order you write your polynomials in. Now we're going to start worrying about it. So we want to write our polynomial such that the highest degree term comes first, followed by the next highest degree term, followed by the next highest degree term, until eventually on the right hand side of the polynomial you have the lowest degree term. If we take a look at the very first example in your cooperative group problems, this would mean that we would write 4x to the second power first because it is second degree. Then we would write plus 3x because that's first degree. And then we would write plus 5 because that's 0 degree. So we would rewrite this as 4x to the second power plus 3x plus 5. Exactly the opposite order that we see here, because that would put us in descending degree order. Notice that the term in front, if it doesn't have a sign, is positive. If it does have a negative in front of it, then it's definitely negative. Once we've written a polynomial into descending degree order, then we can identify something called the leading coefficient, which is the coefficient of the very first term. So we said the first term for number 1 would be 4x squared. Therefore, its leading coefficient is 4. The degree of a polynomial comes entirely from the degree of the first term as well. So that first term becomes really important, and we could ignore all the rest. For number 1, the degree is going to be 2 for the whole polynomial because the degree of the first term is 2. Right? Please make sure you're not combining degrees from different terms when you consider the degree of the polynomial. The degree of a polynomial comes from the first term or leading term only. When you do this cooperative group work, please make sure that you are doing all three things asked for in the instructions. That is, you're writing the polynomials in descending degree order, identifying the leading coefficient, and identifying the degree of the entire polynomial. Our last page gives us a different way to classify polynomials, and that's to classify them according to their degree. We have 4 names that you're going to use here. If a polynomial is degree 0, we call it a constant. If a polynomial is degree 1, we call it linear. If a polynomial is degree 2, we call it quadratic. And if a polynomial is degree 3, we call it cubic. We also have special names for degree 4 and degree 5, which you don't need to worry about. You won't be using them, but they exist. Degree 4 is called quartic, degree 5 is called quintic, and that's it. Anything of degree 6 or higher has no special name. So in this set, you are going to classify polynomials two different ways. You're going to classify according to degree, which is the table right above here on page 118. And you're also going to classify by the number of terms. We looked at a few pages ago. That means you're going to be using words like monomial, binomial, trinomial, or polynomial. And you've been given an example here. 3x to the second power minus 2x plus 1 is a quadratic trinomial. It has three terms, therefore a trinomial. And the leading term is degree 2, which makes the whole polynomial degree 2, which gives it a name of quadratic. That's it for the material in lesson 3-1. Go ahead and give the cooperative group problems a try, and let me know if you have questions.